Okay, I'm going to leave some space. Are y'all okay with me leaving space? In case on the next step I get an x cubed, I want some space for it. Then I have, oh, that should be a minus x to the fourth over 4 factorial. And then I have a plus x to the sixth over 6 factorial. So all that happened is those changed signs, right? Yeah. Now we play the game again, right? We say, what do we multiply this by? 1 to get that.
X squared over 2.
Yeah, that, right? So we go plus though, right? Not minus, plus x squared over 2 factorial. And then we start multiplying that through. This one's going to be a little bit tricky. Trickier? More tricky? More trickier. I like that. That sounds the best. More trickiest. More. Okay, this times 1 is itself. This next one is the most complicated one we've seen so far. This times this. So we get a negative, right? X to the fourth, x squared times x squared. 2 factorial times 2 factorial. This 2 times 2 is 4. So we x to the fourth over 4. Not 4 factorial. Is it minus or plus? Minus x to the fourth over 4. Right, that's our next term?
Yep.
All right, do I need to keep going?
I think so.
Do I need to?
No.
Why do I not need to?
You're going to get the third term.
Yeah, so I know that when I come through and change the signs, this is going to go away, right? And then this is going to pop me out an answer here.
Oh, I see.
And that's what I need to multiply by to get the next term, and I'll have 3 terms, won't I?
Yes.
So I could keep going, but I don't need to keep going. Unless I had asked you for the first 4 terms, then you need to keep going, right?
Also, then you, by process of elimination, know the third term.
I do, because it's going to be whatever this turns out to be, right? So do y'all want me to do another one? I can do another one. I'll do it. Okay, so this times this one, right? We're going to have x to the 6th power on top. It'll be positive. And then on the bottom, I have 2 factorial times 4 factorial. 4 factorial is 24. Oh, I thought I heard 28. I'm sorry. 48. Okay, I thought I heard 28. 48. And then you come through as positive, right? As positive. So now we come through and we change the signs. So subtract. This becomes an add. This becomes a minus, right? And now we add down. Gone. All right, this is really what? 4 factorial is really what? 24. So we have to do these two, right? So that's negative x to the fourth over 24, and we're adding to that x to the fourth over 4. I need a common denominator, 6. So 6 here, that turns that into 24. 5x to the fourth. 5x to the fourth over 24. And then who cares, right?
Yeah.
And now I say again, what do I multiply 1 by to get this? 5x to the fourth over 24. Plus dot, dot, dot. I've given you the first 3 terms of 1 over cosine x. Which means that's the first 3 terms of secant x.
Yes.
Right? Those are the first 3 terms of secant x.
So we just have to list the terms, we don't have to make it a new formula or a series, power series?
You don't, no.
Okay.
Wait, no, you mean turn it into a formula?
Yeah.
No.
I also hate to ask, but so is it safe to assume that this is how we can handle all these types of problems where we have like some sort of familiar power series when we do multiply?
Yeah. And remember, we actually do have a way of coming up with power series on our own, right? Like that whole thing where we made the table and we found the Maclaurin series. So if someone gave us something that we didn't have, we could come up with its power series.
On the test, are you like, I guess, remember like what the cosine x and the power series looks like?
No, you have the sheet. Yeah. Oh, that's important actually. You're bringing something up here. Look at number 7 and number 8 on here. I ask for the Maclaurin series and I say you must derive the series, you may not use the table. Because like for example, e to the 2x, or sorry, e to the negative 2x, right? To find the Maclaurin for that, I could just go over here, kind of like we did with the e to the I x earlier, and I could just replace all the x's here with negative 2x, and that's the answer. But when I say you can't use a table, that means you can't do that. What you have to do is actually do all your derivatives, plug in 0 to all of them, and then come up with your series. The good news is that your answer should match that, like what would happen if you plugged in. You could verify.
The derivatives for e to the negative 2x are all going to be the same thing.
No, well, kind of. The zero derivative of that is itself, right? The first derivative would be negative 2 then this, right? And then the next derivative would be positive 4 times this. So every time you get a negative 2 popping out. So it's going to alternate signs, and it's going to be powers of 2 that keep increasing. Getting annoyed.
Do we have enough time for number 10?
I don't know. What time is it? You know? Well, hold on. Have you requested yet?
No.
No? You want number 10?
Yeah. It's,
Well, 10's going to be easy. Yeah, it's going to take us just a minute. It always looks hard, and then you realize what you need to do, and then you're like, oh, that's it?
yeah, that was what I got up to on the review, so I just saw it and I was like,
So there's only 2 problems on the test where I say that, or on this review, where I say you cannot use that table, the Maclaurin series. So if we're trying to estimate this using the first 4 terms, then what I'm going to do is do the integral from 0 to 1, and what I'm going to do is do the cosine Maclaurin series, replacing all my x's with x cubes. So I go over to cosine, and everywhere I see an x, it now becomes x cubed. So it's going to become 1 minus x cubed squared over 2 factorial plus x cubed to the 4th over 4 factorial. I only need the first 3 terms, right? It said use the first 3 terms?
First
4, okay. Minus x to the 3rd over, x to the 3rd to the 6th over 6 factorial plus dot, 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 right? dx. That is what cosine of x cubed looks like as a power series, as a Maclaurin series.
so you didn't want us to actually integrate that?
No, I'm not done. I'm just saying that's what it looks like, written as a Maclaurin. Then, before I integrate, I'm going to just clean it up. That's 1 minus 1 over 2 x to the 6th plus 1 over 24 x to the 7th or 12th? 12, and then 1 minus 1 over, what's 6 factorial? Big. 720? No. Someone do it. I always forget these. Okay, so 720, is that what I had said? Okay, 720. And then x to the 18th plus dot, 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 right? dx. That's the first 4 terms. And now, enjoy, integrate, right? So the antiderivative of 1 is x minus, okay, here we're going to get 1/7 x to the 7th, which hits the 1/2, becomes 1/14 x to the 7th, plus, okay, the numbers are getting bigger now. How about 1 over 24 times 12, times 13. 13 x to the 13th. I'm just doing power rule now, right? That's it, just power rule. Minus 1 over 720 times 19, x to the 19th. That's it, I'm just using the first 4 terms, 0 to 1.
Also, would you accept that, like on an exam, if you just did multiply out and get 720 times?
That's okay, but you're going to need an answer here, right? So the good news is I'm going from 0 to 1. So when you plug 0 into all of these, you get 0, right? When you plug in 1, you're just going to get the fractions. So your answer should be whatever 1 minus 1 over 14 plus 1 over whatever 24 times 13 is, and then minus whatever 1 over 720 times 19 is. Yeah, get that as a decimal on the test. You'll see how that works? And I'll tell you right now that without the Maclaurin series, we can't do this by hand. We have no way of integrating this. Cosine of x cubed, we don't have a technique.
Is it
Well, if you do integration by parts, you have to choose a U and a dV. So what are you going to choose? You see what I'm saying? It's a composition. So if I try integration by parts, right, like your only choice really for U is cosine x of x cubed, right? And then dV would then have to be dx, and that means that V would have to be x. And then here you're going to get chain rule, so you're going to get 3x squared times negative, let's see, sine of x cubed, and ultraviolet minus the integral of voodoo. Voodoo just got worse than the original, and we can't do it. Even if you go to Wolfram Alpha and type that in, you're not going to get an answer. It's going to be like error function. But do you see we actually could do it like with the series? That's the beauty of the series. Okay, what else?
Like, is this one of those things that it's not integrable?
Yeah, so if you take like the universe of functions out there, right? And well, if you took a big pot, right, of all functions, and like just like close your eyes and reach in and pull the function out, the chance that you could integrate it using the techniques that we've learned is essentially zero. Using our methods, right? We have to make the problems very nice to work. So that doesn't fly in the real world, right? That's what makes series so important, because we can pretty much handle almost everything we see as long as we can get it into its series form. Not only that, when it comes to integration, all power series are easy to integrate because it's just power rule. That's all. Every power series, the antiderivatives are nice.
Why not just go straight to series?
Yeah, why not, right? Why not? Yeah. Well, some of it's messy. I mean, some of it, like if I say, integrate cosine, you don't want to be, you know what I mean? Like there's certain things we just don't want to mess with. Yes?
Can we do number 12?
Wasn't that from a section we didn't go to?
Oh yeah, so number 12 you don't need to worry about. Yeah, so I need to tell y'all where to go if y'all want to do the chapter 9 videos. So I'm going to have to send you an email. I will not include any chapter 9 problems on the final as part of the test, but as bonus I will include chapter 9. And so like on this review, there was number 12 there. Find the points on the curve x equals t cubed blah 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 where the tangent is horizontal and vertical. That's out of 9.2, I believe, or 9.1. And then on the second review that's handwritten, numbers 15 and 16 are both from those sections. It's actually 9.1 through 9.4. Yep.
So things from chapter 7 again, like that?
Could be, yeah, that's on here. Yep. Anybody have a request? I have 20 minutes. Requests? See if my computer comes on. And there should be a button that I can just press to say, come back to life. If I press it, nothing happens. I have to like hold it down and shut it down, then it comes back. It's weird. Not at all. Are y'all going to do any study groups or anything? There is a chance it's not 100%. My Cal 3 class has requested that I possibly do a study session on Sunday. So I'm not guaranteed on this, but there's a possibility that on Sunday I may be coming up here like at 5, opening up a classroom for my Cal 3 to answer questions. So if I do that, I'm going to let you all know as well, so that if you're interested in coming, like the campus is closed on Sunday, but I can let people in as long as I keep an eye on everyone. You know what I mean? So I'll let you know. I don't know. Again, I got to check a couple of things, but connect to the internet.
About how many questions, so are the number of questions on this review about what we would expect on the final?
Well, I don't know. I mean, it's,
Or do we have to really like worry about?
you have 2 hours, 45 minutes. So I think you can agree that the tests that I've given have been, pushing you to the limit of time, right? It's pretty much the same thing's going to be on the final.
Okay.
Yeah, I don't know if it's necessarily number of questions as much as it's just how much time it takes you to do it.
Chapter 7, will we have chapter 7 questions on there?
Could be, yes. The hell was that?
Let's see if I can enter that. Pushing a shopping cart under towards that.
There won't be an emphasis on chapter 7, but I mean there will be maybe a problem or two from there. So you want to be.
I hate volumes, bro. I love volumes. Fucking random. I just don't like anything to read.
I have a video to show you. I try and show this to all my calculus classes.
I'm curious because it's at the end, you know?
It's at the end, so
Oh, God.
let's see. We won't do the projector. We'll do the lights down though. Oh yeah. I'm going to turn off the camera because there's no sense in recording this.